Hello again. Today is going to be lesson 7.5. So go ahead and print out the notes and get them ready. Also, in one of my previous videos, I said something about getting out a calculator and that we would use it, and then I don't think we actually used the calculator in the video, but in this video, we will be using one. So you will need a calculator for this. So go ahead and have one at the ready. I'm just probably going to be using my phone calculator for most of it, but I've already worked out the problems and I have the answers that I've already typed into a calculator. So I will go ahead and I will share my screen. And I'll get started. Okay. So with the other ones we solved, we were relating the bases of the equations. So it would be like the exponential property of equality, where it would be like a to the x equals a to the y, and that means that we can just set x equal to y. But we're going to be solving some different kinds of equations in this one. Ones that do not have the same base. So we're going to use the properties from the last lesson, 7.4. So that is going to be the expanding and contracting properties. And what we need to do before we can solve any of it is to get the equations into one of the two following forms. So log base a of x equals log base a of y. So log equals log, or log base a of x equals just a number or some value there. So in either case, we're going to have one side by itself that is just a logarithm. Okay. So also we'll note that it's only the inside of logarithms can only be positive. So in this video, we will have to check some of our answers. We'll need to check our answers to make sure that they give us positive numbers. And that will be sort of in the second half of the problems that we're going to be doing. Okay. So we will jump, the first half actually, we're going to be checking our answers. And then the second half is going to be a different kind of problem. Then the first half, we will have to check every answer that we get to make sure that is not making the inside of our logarithm either 0 or negative. All right, so we can go ahead and just jump right into it. We first want to get it into one of the two forms that I said right here. So log equals log, or log equals a number or some value. So we can rewrite this side of the equation by using the expanding and contracting properties to rewrite this as a single logarithm. Okay. So we can write it as log base 6 of x plus 3 times x plus 3, where we go from addition of two logs to one log with multiplication on the inside. That equals 2. Okay, so now that is log base 6 of x plus 3 squared equals 2. And one thing that we can do with this one is we can rewrite it as an exponential, or we could write it with this 2, instead of being an exponent on the inside, we can write it as a coefficient on the outside, and that's actually going to be a little bit easier if we do that. So I'm going to write it as 2 times log base 6 of x plus 3 equals 2. And then we can divide both sides of the equation by 2. And so here the 2's cancel out, and we're just left with log base 6 of x plus 3. And then here 2 divided by 2 becomes 1. And then we can rearrange from a logarithmic equation to its exponential form. So if you remember, that was the property in one of the videos, I believe it was 7.1, where if we have log base b of x equals a question mark, we can write it as x equals b to that question mark, where our base, the logarithm becomes the base of the exponent, the argument goes by itself on one side, and then our value, that's the question mark, becomes the exponent. So we can write the same thing here. It can become x plus 3 equals 6 to the first power. And so I'm going to do the colors so you can see where that's coming from. And so 6 to the first power is just 6. So we end up with x plus 3 equals 6. We can subtract 3 on both sides and get x equals 3 as the solution. But like I said in the beginning of this video, we need to check our solutions to make sure that it does not make the inside of the logarithm 0 or negative. Okay, so we want to plug it into the inside of both of these logarithms, but actually since both of these logarithms are the same thing, we only have to check it once. So I'm going to plug in 3 into the inside of this logarithm to see if it gives us a problem on the inside. So log base 6 of x plus 3 is 3 plus 3, which is log base 6 of 6. So that's not, for some reason that didn't write very smoothly. Okay, so since 6 is a positive number, it's not a problem on the inside. So that means that this one is good. And so x equals 3 ends up being our final answer. So we don't have to worry about leaving that one out. Okay, so we'll go on to the second example. So we need it to be in either the form of log equals log or log equals a number. This one will be easiest to get into the log equals log form because we already have logs on both sides of the equation. So all we have to do is make sure that this 2 goes into the inside of the equation as an exponent instead with one of our expanding and contracting properties. I believe it was property number 3. So natural log of x plus 2 squared equals natural log of x plus 14. And so now that we have those as 2 logs with the same, or 2 logs with the same base, so natural logs both have base e's. It's similar to the exponential property of equality, where if you have the same base, you can set the powers to equal to each other. We can also set the insides of these logarithms equal to each other since they both have the same base of e. So we're going to do x plus 2 squared equals x plus 14. And then we will work on solving that. So x plus 2 squared, we'll have to write it as x plus 2 times x plus 2. And then we'll have to multiply that all out. So I use the FOIL method. If anyone has a different method they want to use to multiply that out, go ahead. But if we use the FOIL method, we'll get x squared plus 2x plus 2x plus 4, and then the x plus 14 stays on this side of the equation. And so it's x squared plus 4x plus 4 equals x plus 14. Okay, so I'm going to move this over a little bit to give myself more room. And then write it up here. And so I will move everything to one side, so it is set equal to 0. So subtract x from both sides and subtract 14 from both sides. And get x squared plus 3x minus 10 equals 0. We can factor this into, we can use x and x to factor that x squared. 10 is 5 times 2. And we want a positive 3 on the inside and then negative 10 on the end. So we should do positive 5 and minus 2. So set both terms equal to 0 and solve. We get x equals minus 5 or negative 5, and then x equals positive 2. So before we accept those as our answers, we have to check it and make sure that they don't make the inside of either of our logarithms 0. So we'll have to check both of these. So I'm going to start by checking negative 5. And I'm going to plug it into the inside of this first logarithm. ln of negative 5 plus 2. And that equals natural log of negative 3. So we've already got a negative on the inside when we plug it into the first one. And so it's already causing a problem. So that means that negative 5 is not good. It is not okay to have. And so we're just going to cancel that and not write as one of our answers. So then we'll check 2 by plugging it into this first one, natural log of 2 plus 2 equals natural log of 4. That's a positive number on the inside, so that's okay. And then I'll plug it into the second logarithm. And so natural log of 2 plus 14 equals natural log of 16. And that inside is a positive number, so that means that 2 is okay to plug into both of those. So in the end, we just have one solution for the second equation, or sorry, for the second problem. Okay, give you just a second so you can see the whole thing at once. All right, and so we will go on to number 3. So number 3, I want to take the logarithms on this side and write them as a single logarithm. So we end up in the log of something equals log of something form. And so we can contract this and write it as log base 3 of the two arguments multiplied together. So x minus 3 times x plus 2. And then the other side stays the same. Okay. So now we have it as 2 logs equal to each other. They have the same base, which is 3. So that means we could set the arguments equal to each other. X minus 3, x plus 2 equals 5x plus 1. And then we can multiply that out. So I'm going to use FOIL. So x squared plus 2x minus 3x minus 6 equals 5x plus 1. And then I'll simplify that. X squared minus x, because the 2 and the negative 3 combine to make negative x. And then minus 6 equals 5x plus 1. Okay. And I will move this over a little bit so we have room. And I'll move everything to one side of the equation. So I'm going to subtract 5x from both sides. and subtract 1 from both sides, and end up over here as x squared minus 6x minus 7 equals 0. Okay, so now we can factor this to solve it. So x squared becomes x and x. The factors of 7 are just 7 and 1. And then if we want a -6 on the inside, it works to make a -7 and a +1. And those also multiply together to make this -7 that we need. So now we'll write x minus 7 equals 0, x plus 1 equals 0, add 7, and we get x equals 7. Subtract 1, and we get x equals -1. So before we accept those as our answers, we have to check to make sure that they are correct and that they don't make the inside of our logarithm, inside of any of our logarithms, we end up with 3 that we have to check. We don't want any of those to be 0 or negative. Okay, so I'm going to start by checking 7. So I'm going to plug it into this first one. Log base 3 of 7 minus 3 is log base 3 of 4, which is positive, so that's fine. Log base 3 of 7 plus 2 equals log base 3 of 9, which is also positive, so that one's good. And then log base 3 of 5 times 7, which is 35, plus 1 is log base 3 of 36, which is also positive. So 7 ends up being good. 7 is okay. So then we'll check -1. So if you plug in -1 into the first logarithm here, log base 3 of -1 minus 3, you're already getting that that is log of -4, which is not okay to have inside of a logarithm. So that one's not good. You don't even have to check the rest because it's already something has went wrong. So we will X out that answer that is for, we'll X out the x equals -1. We don't want that one. So this one just has one solution as well. Okay. So here are the questions that we're going to need to use the calculator with. Okay, so we'll be solving logarithmic and exponential equations, and we'll need calculators, and I'll show you specific things that you'll have to do to use to type certain things into the calculator. So this equation 4 to the x minus 8 equals 1970. So we know how to solve things that have x just as a regular number, but not really as an exponent. So we need to rewrite this in its logarithmic form to get x out of the exponent. The fact that it's up there as a power is a problem that makes it less easy to solve. So if we rearrange it into its logarithmic form, we can make that better. So that's using the property that I've been putting a star beside in the rest of the videos. I think I wrote it at the top of this video, maybe. Maybe not. Oh, yes, I did. So this property here. That one. We're going to use that, but we have been going from the log to the exponential. And this one, we're going to go from the exponential form to the logarithmic form. So here our exponent is x minus 8. So that is going to go on one side by itself because that's like a question mark. Then the base is 4. So that is going to be the base of our logarithm. Sorry, I should use yellow. Yeah, the base is 4. So it should be log base 4. And then this number here on the other side, this 1970, which is like this x, which is by itself, is going to go into the argument. And so we'll be using the property I put a star beside and getting into this form, and now we can get x by itself. It's pretty easy to get x by itself. We're just going to add the 8. We're getting log base 4 of 1970 plus 8 equals x. And so it wants the answer as a decimal or a fraction. And so we don't want to write the logarithm in our answer. But this, lots of calculators do not have the option for writing a base as the log. It just automatically puts the log in there as log base 10. So I'll show you how to put that into a calculator. So we're going to put a calculator. So what you want to write in your calculator, instead of log base 4 of 1970, you can write that as just regular log, which has a natural, like the base of 10 is the common log. So that's the only thing the log calculators have. Some calculators do have the capability of putting that base in, and if that's what your calculator has and you're more comfortable with that, go ahead. But if your calculator doesn't have that ability, you can write it as log of 1970 over log of 4, where that log has a base of 10. So that's just the button that automatically comes on it. And so just make sure if you write it, put parentheses around the inside, do log of 1970 divided by log of 4, and you should be able to get that answer. So whenever I plugged that into the calculator, I got something approximately equal to 5.47119. And so that is what is going on here. It is 5.47119. Hold on. Trying to give myself more room. 5.47119 plus 8 equals x, which becomes 13.47119 equals x. And then as the final answer, we want to round it to 2 decimal places. So x equals 13.47 as the final answer. So in my calculations, I typically round it out a little bit further, so usually to at least 4 decimal places or more, until the very, very last step where I'll round it down to 2. Because if you round too early in some of these problems, then it can mess up the final calculation and you could type it into Hawks and end up getting it wrong just because you rounded too early, not because you did anything in particular that was wrong. So just when you stick things into a calculator, round it out to at least 4 decimal places, do the rest of your calculations, and then finally at the very end, round it to 2 decimal places. Okay. So now with number 5, we have 8 to the 3 over x equals 60. So again, we have got an x in the exponent, and we don't want it there, so we're going to rewrite it as its logarithmic form. So here 8 is our base, then 3 over x is our exponent, and 60 is the number by itself. So we can rewrite that as log with a base of 8. and then 60 as the argument on the inside, and 3 over x by itself on the other side. Okay. So now that we've done that, we'll work on getting x by itself. So the problem is coming from the fact that x is in the bottom of the fraction. We don't want it in the bottom, we want it in the top. So I'm going to multiply both sides of this equation by x. We get log base 8 of 60 with x being multiplied on the outside. And then here, the x on the bottom and the x we're multiplying cancel out, and we're left with 3. Then to get this x by itself, we can divide by log base 8 of 60. Sorry, I should be putting parentheses. These logs cancel out, and we end up with x equals 3 over log base 8 of 60. Okay. So now it is calculator time. We need to put this log base 8 of 60 into a calculator. If your calculator has the capability of doing logs with bases other than 10 or e, you can do that. But if not, this is how you will do it. So log base 8 of 60. Type it into the calculator as log of 60 divided by log of 8, or that's just the common log. You could use the natural log there if you want. But we're just going to do the common log that has base 10. And then when you type that into a calculator, you should get something like 1.968964. And it would keep on going, but that's rounded out more than enough. And so we end up with x equals 3 over that 1.968964. And then you can stick that into a calculator again, the 3 over 1.968964, and get 1.5236. And then as the final answer, we will round that to 2 decimal places. And I'm going to write the squiggly lines to mean approximately equal to, because it's not exactly equal because we rounded it. Okay. So that is the final answer for the third example. And I'm checking to make sure my calculations were correct. Good. Yeah, so yet again, don't round to 2 decimal places until the very end. Just round it out a little bit further until your very final calculation. Just at the last minute, bump it down to 2. Okay, so that is the final example on this section. Let me know if you have any questions, or let your teacher know, and I will do the last lesson after this. It should be 8.1, and then that will be all of the lessons for this test 4 sequence.